Hi students, so welcome to the channel. So in this video we are going to do quick revision on the chapter sets for IIIT, as well as these bits are useful for all other competitive exams, so which are based on 10th class syllabus, right? So before getting into the video, if you are new to this channel, so please subscribe the channel and watch the video till the end. So if you like the video, please share with your friends so that it is useful to them, right? Now let us start with the chapter. So first of all, we are going to discuss what are the things that we are having in the sets. So set is nothing but a collection of well-defined objects. So well-defined objects means everyone can easily say what is that, right? So what are the things? So it should have a common property. So set means nothing but collection of all the objects which are having a common property, right? Next, so it is usually denoted by the letters, so capital letters, and the elements. So the objects that are present inside the set are nothing but called as elements. So these elements are generally represented by lowercase letters. So from this we can conclude that every set is a collection of objects, but every collection is not a set, right? Next, to represent a set, so there are two types of representations. The first one is roster form. So other name for roster form is tabular form or list form. The same way you can represent a set as set builder form or rule form. So here you will be writing the given set as a rule. So rule or nothing but we call it as formula, right? Next, so what is roster form? So roster form is nothing but in which we are going to list out the elements separated by commas within the curly brackets. So curly brackets are flower brackets or chain brackets, so these all are the same things. So we will be representing a set within the curly braces and the elements are separated by commas, right? So here belongs to, does not belongs to. So if any element belongs to a given set, then we use this symbol, and if that element does not belongs to that set, then we use does not belongs to symbol, right? So if we are having in roster form, so if any element is repeated, so we are not going to write within the given set, right? Next, moving on to set builder form. So what is set builder form? So in set builder form we are going to write the given set with a property. So the property what it is holding, right? So x says that, so whatever the property that it is given, so that we will be writing here. So based on that we are going to write the set builder form, right? So here we need to remember that roster form and set builder form are two different forms which represent the same set. Okay, next, moving on to types of sets. So first type of set is empty set. So empty set means, so if there are no elements in the set, then we call it as empty set. So other names for empty set is null set or void set. So generally empty set is represented by the symbol phi or with the empty set. So just we will be opening the braces and closing the braces. Next, a singleton set. So singleton set means name itself suggests it contains only one element. So if a set contains only one element, then it is called a singleton set. Next, subset. So subset means if you are having two sets, if every element of one set are present in the other set, then we say that the set A is subset to B. So if every element of set A is present in set B, then we say that A is subset to B. So generally subset is represented by this symbol, right? So in general, if we want to represent, so if A belongs to A, then A belongs to B. So A belongs to A implies A belongs to B. And one more thing, so if A is subset to B and at the same time B is subset to A, it is possible only when A is equal to B. Next, in general in our mathematics we will be observing this. Natural number set is subset to whole number set is subset to integer set is subset to rational number set is subset to real number set. So likewise, so whatever the things that are on the left hand side, so those will be subset to the right ones, right? Next, to represent the set as pictorial representation, so we are having Venn-Euler diagrams. So using Venn diagram, so while solving the problem, so most of the problems will be solved easily by using Venn diagrams, right? So in Venn diagrams we are going to have a rectangle. So this rectangle is nothing but the universal set, and closed curves like circles or ovals will be used to represent a set in this chapter, right? Next, moving on to operations on sets. So there are, so like how we have addition, subtraction, multiplication and division in arithmetics, the same way in sets. So if you want to apply operations, so we are going to have union of sets. So first operation is union of sets. It is like addition, right? So if you are having two sets A and B, the union of set A and set B is generally nothing but the elements of set A or set B or both A and B. So it is generally represented by A union B. So this is nothing but the symbol of union, right? We will be reading this as A union B. So A union B, or sometimes you can read it as A cup B. So if you want to represent this A union B in set builder form, so in set builder form it is nothing but X such that X belongs to A or X belongs to B. So here the word R you need to remember, right? For union, R is nothing but the representation. So if X does not belongs to A union B, that means X does not belongs to A and X does not belongs to B, right? Now from this, if A union B is given, that means A is subset to A union B and B is subset to A union B, right? So set A will be subset to A union B, set B is also subset to A union B. And the second operation is intersection of sets. So intersection of sets means, so you are going to consider the elements so which are present in both the sets. So if you consider two sets A and B, so intersection of A and B is given by the common elements of the set of common elements of A and B, right? So this is nothing but the symbolic representation of A intersection B, and this A intersection B in set builder form, so you will be representing it as X such that X belongs to A and X belongs to B. So end means at a time you need to consider, right? So from this what we can say, A intersection B is subset to A and A intersection B is subset to B. So here it is opposite, right? So you need to observe these two cases. So here A and B are small sets, A union B is bigger set. So A will be subset to A union B, B is subset to A union B. Here A intersection B is the smaller set when compared to A and B, right? Next, moving on to disjoint sets. So what is meant by disjoint sets? So if you consider two sets such that there is no intersection part. So if there is no intersection part, or if there are no common elements in the given sets, then such sets are nothing but called as disjoint sets. So symbolically, if you want to represent, we will be representing A intersection B is equal to 5. So and n of A intersection B. So if you want to count the number of elements, then it is nothing but equal to 0. So 0 is different from 5. So 5 is representing the set, whereas 0 is representing the number of elements present in the set. Next, difference of sets. Next operation is difference of sets. Difference of sets is nothing but, so you will be considering, so if two sets are given A and B, then the element belonging to A and the element does not belongs to B. So before which set we are having this minus symbol, so that particular element does not belongs to that particular set, right? So from this what we can say, A minus B is nothing but represented by X such that X belongs to A and X does not belongs to B. The same way B minus A means, so it will be its opposite, X such that X belongs to B and X does not belongs to A, right? Next is equal sets. So what is meant by equal sets? So if every element of A is present in B, then we say they are equal sets. So that means every element of A should be present in B, every element of B should be present in A. Then in such a case we say that those two sets are equal sets. That means equal sets means so both are having the same elements. Next, equivalent sets. So there is a difference between equal sets and equivalent sets. So equivalent sets means if number of elements are same. So if in two sets equal number of elements are present, then we say those sets as equivalent sets. So from this we can conclude that all equal sets are equivalent sets. All equal sets are equivalent sets, but its converse is not possible, right? All equivalent sets cannot be equal sets, but all equal sets are equivalent sets, right? Next, moving on to finite set. So if you count the number of elements. So if there are countable number of elements in a given set, then we call them as finite number of set. So finite set, right? So if you are having infinite number of elements, then we call it as, so if we can't count the number of elements in the given set, then we call it as infinite set, right? Next, cardinal number. So cardinal number is nothing but it is representing the number of elements present in a finite set. So it is generally represented by n of a. If a is the given set, n of a is nothing but the representation for cardinal number. Next, so there are certain points which we need to remember. See, this is empty set and this is the set which containing 5 as one of the elements. So these two are not equal. The same way, this is empty set and this is a set containing element 0. So these two sets are not equal. That means this set is not empty set. The same way here. So generally empty sets we can represent like this. Next, n of 5. So number of elements in a null set is 0. Next, every empty set is a finite set. So every empty set is a finite set. Likewise, so we are going to have some of the formulas so which we can use in this chapter. So n of a union b is represented by n of a plus n of b minus n of a intersection b. So if the given a intersection b is equal to 5, so if a intersection b is equal to 5, then directly what I can say, n of a union b is equal to n of a plus n of b. So n of a union b is equal to n of a plus n of b. So these two formulas generally we are going to use to solve the problems, right? Next, moving on to the Venn diagram. So already you know about Venn diagrams, right? So if you want to say if a is subset to b, a is subset to b, that means so this inside set is a and outside set is b. So from this is a subset to b. Next, if you want to represent a union b, so if this set is a, this set is b, then this whole shaded part is nothing but a union b. Next, the same way, if I want to represent a intersection b, so a intersection b is nothing but the common part. So this is nothing but my a intersection b part. Next, a minus b, b minus a. So if this is set a and this is set b, then a minus b is nothing but only a. So if you consider only a, then it is a minus b. So this is representing a minus b. The same way, if you want to consider b minus a, then if this set is a, this set is b, then only b is representing b minus a. Next, symmetric difference. So a delta b. So a delta b is represented by a minus b union b minus a, or so there is one more representation which is nothing but a union b minus a intersection b. So if you want to represent this as Venn diagram, so simply what you can say, so you need to fill only a and only b. So this represents a delta b, right? So these are nothing but the conceptual things which we need to remember, right? Next, moving on to the questions. See, a is a set of factors of 12. So factors of 12, so what are the factors of 12? So 1, 2, 3, 4, 6 and 12. So what is asking, which one of them among them is not a member of the set A? So not a member of the set A means does not belongs to set A. So from the options, so clearly 5 is not present in this set, so 5 is the answer. If A is equal to ABCD, if A is equal to ABCD, that means how many elements are there? So there are 4 elements, right? How many subsets does set A have? So since we did not discuss about subsets, so subsets is given by 2 power n of A. So if set A is given, then 2 power n of A is nothing but the number of subsets. So from this what we can say, 2 power 4, which is nothing but 16. So answer is 16. If P and Q are disjoint sets, so if P and Q are disjoint set means there is no common place. That means this is P and this is Q. So P minus Q. So P minus Q means, so if you want to subtract, so there is no common part. So this whole P is nothing but my answer. Then what is the answer? P minus Q is nothing but P. Next, set builder form of set A is equal to 3, 6, 9, 12, so on 30. So if you observe all these, so these all are nothing but multiples of 3, no? So if you want to represent multiple of 3, so you can simply call it as 3n. So in which option we have 3n? So option A. Next, moving on to the number of subsets of A are 32. So number of subsets of A. So for example, if I consider the number of subsets is equal to 2 power n. So 2 power n is equal to 32. So 2 power n is equal to 32 can be written as 2 power 5. On comparing, so number of elements in the given set is 5. So from this the answer is 5. Next, moving on to more question. So cardinal number of null set is, so what is the cardinal number of null set? So cardinal number of null set is 0. So whenever you are asked about cardinal number, you need to think of a number, right? So cardinal number of null set is 0. So other representation of that is n of 5. So n of 5 is also 0. So what is the formula of n of A union B? So before that, what he has given, if A and B are disjoint sets. So disjoint sets means A intersection B is equal to 5. That means n of A intersection B is equal to 0. So clearly option B is nothing but the answer, so which we have already discussed. So which of the following, so in the following which one is infinite set? So he is asking about infinite set. So natural numbers less than 10. So natural numbers less than 10 means you are having set of 1 to 9. So we can count the number of elements, right? Next, whole numbers less than 10. So 0 to 9. So set of 0 to 9. So we can count it. Next, C, integers less than 10. So integers less than 10 means, so integer means, so what is an integer? So you can take negative values also, no? So totally you can go till negative infinity. So that means totally we are having the integer set. So all the integers are infinite set, right? Next, if A and B are disjoint sets, so he is telling you A and B are disjoint sets. So if A and B are disjoint sets, what do you know? So n of A union B is equal to, we know the formula, no? So n of A union B is equal to n of A plus n of B. Now since we know all the values, so n of A union B is equal to, so 8 is equal to 5 plus n of B. So when I transpose this, so from this what I am going to get, n of B is equal to 3. So answer 3. The smallest set A such that A union 2 comma 5 is equal to 1 2 4 5 6. So what he has given, so set of A union set of 2 comma 5 is equal to set of 1 2 4 5 6. So what is he saying? You need to consider smallest set A. So already 2 5 is there, no? So instead of 2 and 5, so what are the things that I need here? So I need 1 4 6. So when I fill 1 4 6, then I can simply say this is the smallest set A. So what is the answer then? Set of 1 4 6. So if he ask about the largest set, so if you say about largest set, then what will you consider? This whole set you can take it as the largest set, right? Next, moving on to one more question. So what is given? So what is given? Set A is nothing but factors of 15. So what are the factors of 15? So 1 3 5. Next, so directly 15. Next, what about set B? Set B is nothing but factors of 18. So what are the factors of 18? 1 2 3 6 9 18. Now what did he ask? A intersection B. So A intersection B means the common things. So 1 is common, 3 is common. Next, so there is no other value other than these, right? So intersection is 1 comma 3, set of 1 comma 3. If A and B are disjoint sets, if A and B are disjoint sets, then A intersection B. So what is A intersection B? So if they are disjoint, then A intersection B is 5. Number of subsets to a null set. So number of subsets to a null set. So null set contains how many elements? 0 elements. So directly number of subsets is 2 power 0. 2 power 0 gives me 1. So the answer is 1. If A intersection B is equal to 5, that means they are disjoint sets. N of A intersection B is equal to 0. Next, if A is equal to X such that X not equal to X, so is there any case where X is not equal to X? So if such case is possible, then there is no such X such that it is not equal to itself. Then such a case is nothing but we call it as empty set. So there won't be any X present in the universe where it is not equal to itself. Okay, so it is empty set. Next, what he has given, A is subset to B. A is subset to B. So what is given, n of A is equal to 12, n of B is equal to 20. Now what he has given, A is subset to B, no? So when A is subset to B, these 12 elements will be there in these 20 elements, right? These 12 elements will be completely present in these 20 elements. So now what is he asking, n of B minus A. So n of B minus A means simply, so we need to remove all the elements of A. We need to remove all the elements of A that are present in B. So out of 20 elements, these 12 elements we need to remove. Then how many elements will be left? So totally 8 elements will be left. So the answer is 8. Next, moving on to one more question. So which of the following sets has only one subset? So which of the following has only one subset? Right? So just now we have discussed, so only the null set is having only one subset. So null set is generally represented by empty braces. Next, n of A is equal to 12, n of A intersection B is equal to 5. So what he has given, n of A is equal to 12, n of A intersection B is equal to 5. Now what is he asking, n of A minus B. So n of A minus B means, so how many elements are common here? So there are 5 elements common. So those 5 elements I need to subtract from 12. So what is the answer then? So 12 minus 5 is 7. So answer is 7. Next, if A intersection B is equal to 5, A intersection B is equal to 5, then n of A in B. So directly we know the formula, n of A plus n of B. So 19 plus 12. So 19 plus 12 is 31. So answer is 31. Next, x such that x is a prime number and a divisor of 6. So what is he asking? So first of all, here end condition is there, no? So we will be taking end means, so what do you know by end? So end means intersection. So first of all, first statement you read, so x is a prime number and a divisor of 6. So first of all we will be considering prime numbers in this set and divisor of 6 in this set. So what are the divisors of 6? So 1, 2, 3, 6. Here what we have, 2, 3, 5, 7, 11 and so on. So what is the intersection part for this? So 2 and 3. So from this what is the answer? 2, 3. So answer is 2, 3. Next, if A is equal to x such that x is an integer. So x is an integer means, so we will be having from minus infinity to plus infinity. And so since he is giving end, so intersection minus 2 to plus 3. So here minus 2 less than, that means we should not consider minus 2. That means it starts from minus 1, 0, 1, 2 and 3 we can consider, because here equal to 3. So what is the answer? So this is universal set. So universal set intersection a small set. So what is the intersection part? So we are going to get minus 1, 0, 1, 2, 3. So minus 1, 0, 1, 2, 3. So option D is my answer. Next, A subset to B. So if you observe this, so A is completely present inside B. So that means what we can say, A is subset to B. Next, here this is the common part. So common part means intersection part only, no? So you can simply say that it is A intersection B. Next, moving on to the next Venn diagram. So if you observe this, only B part is filled. So this is nothing but we call it as only B. So only B means, so only B means, so we need to consider B minus A. Next, if you observe this, we are having only A and only B. So if you are having union of only A and only B, that means it is nothing but A delta B. So A union B minus A intersection B. So this is also called as A delta B, right? Next, moving on to one more question. So P is set of factors of 5. So if I write, so P is equal to set of factors of 5. So 5 is a prime number, so we will have only 1 and 5. Next, Q is factors of 25. So 25 means, so 1, 5 and next 25. Next, R is a set of factors of 125. So 1, 5, 25, 125. Now what is he asking? So which among the following is false? So P subset to Q. So P subset to Q. So all the elements of P are present in Q, no? So this is correct. Next, Q subset to R. So this is also correct. R subset to P. So here if you observe, so R is having more number of elements compared to P. So this is false. Hence this is my answer. Next, P is subset to R. So P is subset to R. So clearly option C is my answer because he is asking in the false statement. Next, if A subset to B, then which of the following is true? So A is subset to B, then which of the following is true? So A subset to B means, so A is subset to B, that means the figure looks like this, right? So this is A and this is B. So if we take the union, then we are going to get the total part only, no? That means, so this is correct answer. A intersection B is equal to A. So what is the common part for these two? So A intersection B is equal to A is also correct. Next, A minus B is equal to 5. A minus B is equal to 5. So from A, if you remove B, since A is a smaller set, no? So when you remove all the elements of A from B, then automatically you are going to get 5. So from this what we can say, all the above. So all the three options are correct, right? Next, A minus B, B minus A and A intersection B are always. So if you observe the figure, so this is A minus B, right? So if this is set A and this is set B, this is A minus B and this is B minus A and this is A intersection B. So if you observe these three meshed parts, so all these three parts are not touching each other, right? So that means these three are disjoint sets. So these three sets are disjoint sets. Next, set A is equal to set of prime numbers less than 6. So set A is nothing but set of prime numbers less than 6. So what are those prime numbers? So those are nothing but 2, 3 and 5. So 2, 3, 5. Next, set B is nothing but prime factors of 30. So prime factors of 30 means, so 30, how will you get? So 5, 6 is 30. So this 6 I can write it as 2, 3, 5. So 5, 3 is 15, 15, 2 is 30. So prime factors of 2, 3, 5. Next, what is he asking? Option A is equal to B, option B A not equal to B, option C A is equal to B is equal to 5, A intersection B is equal to 5. So clearly both the sets are equal now. So directly I have considered A is equal to B. Next, if A is equal to 5, B is equal to 5, then so what is the correct answer? So A is empty set, B is empty set. So what is A union B? So A union B is 5. A intersection B is also 5. So option 1 is correct. Next, A minus B is equal to A, because from empty set if you remove an empty set, so again you are going to get empty set. Next, B minus A is equal to B, because all the sets are empty sets. So directly all the above is the answer. If set A has 3 elements and set B has 6 elements such that A subset to B, then N of A union B. So N of A union B is nothing but the biggest set, right? So whenever you talk about A union B, then you need to consider the bigger set. So what is the answer? So it is nothing but 6. Next, moving on to the next question. So what he has given? So which of the following is not a singleton set? Which of the following is not a singleton set? Now let us see this. So option A. So option A, what is that? So x, that's that 3x minus. So what he has given? X such that 3x minus 1. 3x minus 1 less than 5. So if you observe this, so from this what I am going to get? 3x is less than 6. That means x is less than 2. Right? So x is less than 2 means, so you can consider x is equal to 1 here. So that means it contains one solution. So that means this is set of 1. Next, option B. So if you take option B, so what is given? 20x minus 39 is equal to 0. So from this, x is equal to 39 by 20. So 39 by 20 means, so this is nothing but some 1.5. So this is not a natural number, no? So this is not a natural number. So So this is 1 point something. So this 1 point something is not a natural number. So clearly it is empty set. That means it is not a singleton set. Next, x is a prime number, x less than 3. So that means this is a set of 2. Next, x minus 2 is equal to 0. That means this is equal to x is equal to 2. Again, this is a set of 2. So from this, these 3 sets are singleton sets and this is empty set. Because we are getting 39 by 20. So 39 by 20 is nothing but some 1.9 something will come. So which is not a natural number. So clearly this is not a singleton set. Next, A subset to B. What he has given? A is subset to B. So A is present inside B. Now what he has given? A minus A intersection B. So from this figure, what is A intersection B? So A intersection B is nothing but A only, no? So A minus A. So what is A minus A? A minus B, A is nothing but 5 only, no? Right. Next, set builder form of null set. So already we know set builder form of null set is x such that x not equal to x. And remaining if you observe, so here you are going to get x is equal to minus 1. That means this set is minus 1. So this gives me the set x belongs to natural numbers, no? It satisfies plus 2 minus 2. But here since he is talking about natural numbers, so we need to consider set of 2 only. So here x belongs to natural numbers and x minus 1 into x minus 2 is equal to 0. That means this contains this elements 1 comma 2. Next 1 3 4 6. So you need to do the matching here. So 1 3 4 6. So 1 3 4 6 is a finite set. So clearly this is B. X such that x is a multiple of 2. So multiples of 2 how many will be? So they are infinite number of multiples of 2. So this is C. Next, x such that x belongs to natural number and x less than 1. Right? So this is an empty set. So what is the answer? B, C, A. So where I am getting B, C, A? So option A. Next, A is nothing but factors of 6. So A is equal to factors of 6 means, so 1, 2, 3, 6. Next, B is nothing but factors of 18. So what are the factors of 18? 1, 2, 3, 6, 9 and 18. Next, factors of 36. So 1, 2, 3, 4. Next 6. Next 9, 12. Next 36. So 18 also will come, no? Right? So 18 comma 36. Now what is he asking? So all the elements 1, 2, 3, 6. So 1, 2, 3, 6. Here also 1, 2, 3, 6. So A is subset to B and C. So A is subset to B as well as A is subset to C. Next 1, 2, 3, 6, 9, 18. 1, 2, 3, 6, 9, 18. So here clearly B is subset to C, no? So by taking the transitive property A subset to B, A subset to B subset to C. So from this A subset to B subset to C. Right? So the answer is A subset to B subset to C. Next, moving on to one more question. So if A subset to B and B subset to A. So if both the things are happening at the time, so then directly A is equal to B. So minimum number of subsets of a non-empty set are. So how many subsets for a non-empty set? So what is meant by non-empty set? So non-empty set means it should not be an empty set. So minimum number of elements in a non-empty set. So non-empty set means the minimum number of elements in a non-empty set is 1. So total number of subsets. So it is nothing but 2 power 1 which gives me 2. So answer is 2. Next, which of the following is true? If A is equal to 1 comma set. So this is also one of the elements present inside this set. So 4 comma 5 comma 5. Then so set of 1 comma 2. So set of 1 comma 2 is nothing but one of the elements present inside this particular set A. Then this is true. Next, set of 4 comma 5. So set of 4 comma 5. So this is one element, this is one element. So when you take two elements, then this becomes a set. So when you take a set, it should be subset. So hence it is wrong. Next, set of 5 belongs to A. So whenever you are considering set, that means you need to make use of the symbol subset. Hence it is wrong. Next, here also set of 1 you are saying. So hence it is wrong. So whenever you are having set, you need to make use of subset symbol. Right? So clearly here from the question, so set of 1 comma 2 is one of the elements that is present in A. Since this is a element, so element means we are using belongs to, hence option 1 is the correct answer. Next, A is equal to set of quadrilateral. So set of quadrilateral means all the things will come, right? So what are the things that you are going to get? So quadrilateral will be parallelogram, trapezium, rhombus, rectangle. So you will be having square. So these all are nothing but the quadrilaterals we have, right? So set B is nothing but square, rectangle, trapezium, rhombus. Now which of the following is true? So if you observe this, set B is the smallest set when compared to set A. So clearly B is subset to A. So B is subset to A. Next, A and B are disjoint sets. So disjoint set means there is no intersection. So clearly n of A union B is equal to n of A plus n of B. So n of A union B is 10. So how much should be added to 4 so that it becomes 10? So the answer is 6. Next, if A subset to B and B subset to A subset to B and B subset to A, then A equal to B. So already we have done here, right? Next, identity in the union of sets. Identity in the union of sets. So what is the meaning of identity? So what should be taken as union, so that again you need to get A only. So clearly if you take A union phi, again you are going to get A, right? For suppose if you take mu, so that is nothing but universal set. So A union mu gives you mu but not A. So that means what is the answer? So under the union of sets, what is the identical set? It is nothing but phi. The same way, A intersection what is equal to A again. So A intersection what is equal to A again. So it gives me mu. So from this, for intersection it is mu, for union it is phi. For union it is phi, for intersection it is mu, right? Next, moving on to some more questions. So n of A is equal to 15, n of A intersection B is equal to 8, n of A union B is equal to 19, n of B is equal to. So already we know the formula. N of A union B is equal to n of A plus n of B. So this is what we don't know, minus n of A intersection B, right? So when I subtract this, so I am going to get 4 here. So when I transpose this minus 8, so it becomes plus 8. So 4 plus 8 is equal to n of B. So n of B is equal to 12. Next, A subset to B. That means all the elements of A are present inside B. Then what are the number of elements that are common? So since all the elements are of A are present in B, so that means only those elements will be in common, right? So answer is 5. Next, if A subset to B, n of A is equal to 6, n of B is equal to 10. Then what is he asking? N of B minus A. So n of B minus A is nothing but n of B minus n of A directly. So what is the value? 10 minus 6, which gives me 4. So the answer is 4. Next, n of P is equal to 25. N of P intersection Q is equal to 5, right? Next, n of P minus Q. So n of P minus Q means, so n of P minus n of P intersection Q. So n of P minus Q is nothing but n of P minus n of P intersection Q. So from this directly what I can say? 25 minus 5, which gives me 20. So answer is 20. Next, if A subset to B, n of A union B is equal to 15, n of A intersection B is equal to 10, right? Then what is the value of n of A and n of B? So here if you observe, so n of A intersection B. So what is n of A intersection B? So n of A intersection B is 10. That means 10 elements are common for both A and B. That means from the option simply what we can say? So since both the sets should have minimum 10 elements in both the sets, so 10 comma 15 is only option, so which we can consider here. Next, set A is equal to x such that x belongs to z. So x is an integer and x plus 2 less than 4. So x plus 2 less than 4 means, so x is less than 2. So x less than 2 means how many elements you are going to get? So you are going to get infinite number of elements, because negative we are having no, so it is nothing but infinite set. Next, x says that x belongs to natural numbers. X is a perfect cube less than 300. So from this what we can say? Set A is, So 1 cube, 2 cube, 3 cube, 4 cube, 5 cube. What is 6 cube? 216. 7 cube, 343. So it is crossing. Next, set B is what he has given. So x belongs to natural numbers and multiple of 3 less than 300. So multiples of 3 less than 300. So what are the things? So 3, 6, 9 and so on. So before 300 what you are going to get? 297. So what is A intersection B then? So A intersection B, what you are going to get? So the common values, right? So 3 cube, next 6 cube, next what you are going to get? So what are the values that we are going to get? Only the cubes. So 2 cube and 6 cube, because these contains the multiples of 3. So what is the answer? 27 and 216. So answer is 27 comma 216. Next, moving on to some more problems. So if A is equal to prime number less than 20, so A is prime number less than 20. So set A is equal to what you are going to get? 2, 3, 5, 7, 11, 13, 17, 19. So these are nothing but the prime numbers less than 20. Next, B is equal to whole numbers less than 10. So 0, 1, 2, 3, 4 and so on, 9. Now what is he asking? A minus B union. So A minus B intersection B minus A. So what is A minus B? So A minus B means you need to consider only the elements of A which are greater than 10, right? So from this A minus B is equal to 11, 13, 17, 19. Next, the same way B minus A. So B minus A is nothing but, so from B we need to subtract the elements of A. So that means we need to remove all the prime numbers. So what I am going to get? 0, 1, 4. So 5 will be gone. 6, 7, sorry 7 won't be, 8 and 9. So A minus B intersection B minus A. So is there anything that is common from these two? So there is nothing that is common, so hence it is 5. Next, A is subset to B. So A is subset to B means, so this figure won't come, right? Next we need to go with A then A intersection B is equal to A. So that means which figure represents that? So option C is nothing but the thing that represents A intersection B is equal to A. Next, moving on to some more questions. So n of A is equal to 8, n of B is equal to 5. Then the minimum number of elements in A union B. So if you want minimum number of elements, so you need to take more number of elements in A intersection B. So if you want minimum number of elements in A union B, then you need to take maximum of A intersection B. So among these two, so what is the maximum intersection that we take? So we can take is, so 8 and 5. So what is the common thing that we can take? So common thing we can take is 5. So from which, so n of A and B, what is the formula? 8 plus 5 minus 5. So which gives me 8. So what is the answer? 8, right? Next, n of A is equal to 6, n of B is equal to 4. Then maximum number of elements in A intersection B. So among these two, so what is the maximum that we can take common? So maximum that we can take common is 4. So from here we are having 6 elements, here we are having 4 elements. So maximum how many elements we can take common is 4 elements, right? Which of the following one is incorrect for two equal sets A and B? So if two sets are equal, then which statement is false is asking. So if two sets are equal, then they are equivalent sets. So n of A is equal to n of B. So this is correct. A is equal to B. This is also correct. A minus B. So if we take, if both are equal sets, so when you do difference, it will be equal to 5, right? Then this is not possible. So this is nothing but my incorrect answer. Next, number of solutions of a linear equation with two variables is an example for. So already we know ax plus by plus c is equal to 0. So if you take one linear equation, so then what I can write it as, so y is equal to minus c minus ax by b. So when you substitute values for x, then we will be getting different values of y. So how many solutions we are going to get? So we are going to get infinite number of solutions. So answer is infinite set. So by considering the values of different values of x, we are going to get infinite number of values for y, right? So this is only for one linear equation. So if he has given two linear equations, then they may depend on the given linear equations, given pair of linear equations, right? So if it is other than two variables, if only one variable is given, then it is a singleton set. Then it is a singleton set. So remember, so for one variable, so if it is one variable, then the answer is singleton set, right? Next, for the remaining cases, so for pair of linear equation in two variables, so we are having three cases now. So unique solution, next infinite solutions, no solution. So this no solution comes under null set, this unique solution comes under singleton set, this infinite solution comes under infinite sets, right? So this is about this question, right? Next, the number of subsets of a set with cardinal number 10. So if cardinal number 10 is, then 2 power n, which is nothing but 2 power 10. 2 power 10 is 1024. So the answer is 1024. So if a minus b is equal to 5, a minus b is equal to 5, that means there is no element left over when a is subtracted from b. So from this what we can say, if a minus b is equal to 5, so a minus b is equal to 5 means the relation is a is subset to b, right? A is subset to b. So if you see this, so if this is a, this is b, so from a b is removed. So from a, if b is removed, so what is left? So there will be nothing left here. So that is the answer, a subset to b. So n of a minus b is equal to 16, n of b minus a is equal to 10. Now from this you can understand this particular question. This only a is represented as a minus b, this only b is represented as, so this is a minus b, this is b minus a, and this part is a intersection b. So the combination of these three is nothing but given as a union b. So a minus b union, so n of a minus b plus n of b minus a plus n of a intersection b gives me n of a union b. That means if you add all these things, so 16 plus 10, 26, 26 plus 5, 31. So the answer is 31. Next, n of a is equal to 21. So n of a is equal to 21, n of b is equal to 43. Then the greatest and least values of n of a union b. So what is the formula of n of a union b? So n of a union b is equal to n of a plus n of b minus n of a intersection b. So if you want to get the greatest and least values of a union b, so it completely depends on intersection value, right? So if you want the greatest value, so if you want the greatest value, it should be least. So what is the least possible value for this? So it is nothing but 0. That means directly we can add these two. So 21 plus 43, so 21 plus 43 is 64. So where 64 is, so 64 is present here. The same way we are going to talk about least also. So if this is least, that means this should be maximum. So what is n of a intersection b? Maximum. So maximum is possible is 21, right? Because for 21 and 43, among these two, the common thing that we can take is 21, right? So from that what we can say, 21 plus 43 minus 21. So 21 gets cancelled, 43 is remained. That is option D is my answer, right? Next, if set A is equal to PQ or ST, so how many elements are present? 5 elements. Then proper subsets of A. So what is he asking? Proper subsets, not subsets, right? So if you want subsets, so subsets is nothing but given by 2 power n, which is nothing but 2 power 5, which is 32. So this is subsets. So all the subsets are represented like this. Next, if you want proper subsets, so proper subsets is nothing but 2 power n minus 1. So this is nothing but the formula for proper subsets. Already we have found 2 power n value, so 32 minus 1, 31, right? So the answer is 31. So if you ask proper non-empty, so if you say proper non-empty subsets, then the formula is 2 power n minus 2, then answer will be 30, right? So there are three possible cases. So if you ask only about subsets, then directly 32. Next, if you ask only proper subsets, then 31. If you ask about proper non-empty subsets, then it is 30, right? So these all are nothing but the questions related to sets, right? So thank you for watching the video and all the best for the exam, right? So thank you for watching.